So, hello. Uh, I'm going to talk. Thank you for the introduction, Lorenzo. Uh, I'm going to talk about how do we do recordings of the conference we are managing. Let me introduce a bit. I work for Quobis. Is a company established in 2006 and doing WebRTC stuff since 13. So I think we were one of the earliest adopters of WebRTC, trying to put them on the enterprise. Our customer, what we deliver is some unified communications experience to our customers, both in the desktop through desktop as the browser, and mobile applications with video conference, obviously, chat, integrated contact lists, and so on. This is what our commercial name for the product is. The SIPO product family is composed of the application server, where we manage all the contacts, the integrations with existing enterprise services, etc. We have our signaling server, as discussed in other talks. Everyone wants his own signaling server. We have, of course, Genius as the WebRTC server, and our unified communications clients are mobile and desktop mainly. And we also have an SDK that we can provide to customers that already have their client side, their web interface, that they just ask us to integrate the video conferencing or chat or contacts, but in an existing application. So we have both JavaScript, C++, if you wanted to put it on some IoT deployments, and native SDKs for Android and iOS. Okay, just a bit about me. I graduated as a telecommunications engineer, and I've been working with Quobis since 2013. As Lorenzo said, I'm mostly just doing backend stuff. I'm giving my first talk right now, so bear with me if there is something. And my favorite pizza might be capriccioso, no pineapples. Okay, so let's go into interesting stuff. I will be presenting the recording problem as we faced it in our deployments. We'll try to depict a bit the solution we took, and after we'll see some of the ongoing work we're doing to improve a bit our solution. What we provide is our system is capable of doing the end-to-end calls between the different networks. So we are not strictly confined into the WebRTC, but also we can place calls onto SIP networks, even PSTN or whatever can be reduced actually to SIP. Okay. Currently, our recording scenarios does not involve user-enabled recordings. We choose that because the scenario itself mandates the recording, so there is no UI to activate or deactivate the recording. What we are fetching from Janus, from the recording file that Janus provides, is only the video stream, because as we will see, because of the interconnections we do with SIP and PSTN, the audio is fetched from an audio mixer. Okay, it's not obtained from the Janus MGR file. It's Asterisk who actually dumps the file, and we will get that from them. And the post-processing we will do will be triggered by a message in a RabbitMQ queue that our signaling server and application servers will decide when this happened and will send the message so we can start the processing of the recording. That's a summary of our overall architecture, the scenarios we are working on. The upper part is not relevant for this talk, but it's added for completeness. Is the part of application server deals with the authorization of the users, managing contact lists, schedule conference, etc. What we will focus here is in the lower part, the blue one, the recording box. Okay, we have the media server, the turn, etc., and the storage and the post-recording script. This is what I mentioned before, that we actually connect with existing enterprise elements that may exist. Just a bit of a recap of how Janus itself is providing the base for the recording process. Janus generates the MJR files, which for each of the streams. And with the utility, the Janus pp-rec, we can extract the actual media from those files. The RTP packets are sorted and dumped into a file without any kind of transcoding. Just the codec used for the conference is there, and it encapsulates with the multimedia container that corresponds. We can also add this file for a JSON file, so we can get the start time and some metadata about the recording that we will use later on. Okay, so what implies to record the talk, conference or whatever? We can start by saying that each of the participants of a conference might not have the same role. So we can have some multi-party conference where all are participating in the same manner. There is no presenter or director of the conference, but there might be situations where they are. So we may have this talk, for example, where I'm the presenter. I may want to share some presentation. It's not the same case of a meeting around the table, for example. And the number of participants might not be, usually it's not the same. So we can have people going in, people going out, and this will imply that later on the final result of the recording, the layout is not fixed. We might have to take into account video resolution in order to build the grid or whatever the layout we do. We may want to make sure that audio and video are synced to don't have delays between the voice and the video. And we for sure have to take into account that once the conference is finished, the recording will probably not be immediately available. We might as well have other kind of issues, not so technically related, but business requirements and legal requirements. Other talks have talked about this before, that local specific regulations, or also depending on which business we are targeting to. Okay, I will try now to explain what is our current solution. We start the recording, obviously, once the conference is finished on that Rabbit message I told you before. currently have no scenario with more than 9 participants. So our current solution doesn't involve in calculating a bigger matrix for the output. We don't add at any transcoding step. We just uh, assume the coding used during the conference itself, and we we haven't any requirement to do transcoding, so we can deliver the recording faster. And we just do some basic audio and video synchronization. As I told before, the audio is coming from the audio mixer and the stream from Janus. Uh, the starting times are not exactly the same when the files exist on disk. So we get the time of each of the streams and we align them, because usually it's the audio file that starts earlier. So we just drop the first seconds from it until we match the timestamp we got from the MJR file. And obviously we always make sure servers are NTP synced, because we usually don't have that on the same machine. The both files are not generated in the same machine. And that was the blank audio part I was referring to. This is a high-level view of what the process is. All start on the lower left corner. We have the Janus wrapper, what as we call that, is the it's the front end we will use to speak to Janus and other parts of our internal architecture, and it will be the responsible of emitting that RabbitMQ message notifying of the conference finishing. We see two queues there. The green one is the one where where this message will end up, and will be picked up from the recording master. Is the one orchestrator for each of the steps that we have to do. The first step is the pre-process, is extracting the audio files or video files, sorry, from the MJR files generated by Janus. We do that for each of the streams, and we ask with the Janus ppreg file for the JSON metadata. We process those JSONs to obtain each of the time spans where each of the streams is present. So we can build up some kind of timeline of each of the video files that we will have to compose, sort them, and build the grid or the layout we choose, taking into account how many streams are present at each point in time. With all this information prepared, we build up a ffmpeg command and take all those files and the audio file from the audio mixer and mix them up and store into the disk the final resulting video. And that video is composed with all the streams that have been taking part in the conference and keeping the layout according to how many people were there in the conference. In any case, one of these process throws an exception or whatever, error occurs, the recording master will emit an event that gets recorded in another RabbitMQ queue that will eventually pick up again, check the logs, and trying to rerun if applied. This is what we are currently doing for our recording necessities. And ongoing work we have now is something that we have thought that may be interesting to have. It hasn't been required currently by any customer, but we think that it will be in some near future sometime. So we would like to add some more metadata from the conference itself, like the events of the browsers, the metadata information about where the clients are coming from, what the subject of the conference might be, or subjects in topics that might change. You want, maybe you have a long session, you want to speak first about one topic, later on about another one, and you want to tag the resulting video with each of the topics, so you can then skip to the corresponding part when viewing afterward the recording. Keeping track of the active speaker, so we can specify a specific layout or a presenter role, incorporate that scenario that we talked before that we currently don't have, but it might be interesting to have the discussion topics. And one feature we don't currently have integrated in our current solution, but we are doing in a separate process, is to encrypt the final recording. This is required by some customers that have strict privacy requirements, and it's currently done in just a script that is run afterwards. We will want to incorporate that in the same overall process. And also user actionable recordings. Will be interesting that in some situations, in the case of a call center, for example, that we have just seen, by default, maybe we don't want the recording to take place, but maybe given the type of support we're giving, the agent might be interested in or obligated to start a recording of that call. Okay, that's the approach we took because those were our requirements. But as talked in another talk this morning, there was another approach that is the spy client, I call it, that you have another party joining the conference and that party doing some kind of screen recording, right? You can record as well external content that is not going through the media stream actually. So you can, with another approach that is using local recording at the browser, you can also record whiteboarding sessions, shared tabs in other browsers, etc. In our scenario, this is not useful for us currently because what we actually need is the video and audio from the conference. But might be interesting as it was in the other presentation we listened to this morning. And that was the last minute slide following David's talk. So I will give you a summary. So we saw that each of the requirements will obviously guide how we do the recordings. Janus is giving us a good starting point to build our recording processing and mixing, so that's nice. And the main job of the recording process is to keep all the stuff in place, to mix it up and keep it in sync. And as we have seen, radically different approaches may be useful in other scenarios. That's what we have working now. Might not be, it's not obviously the only solution and might not be yours depending on your requirements. And as we have shown in our ongoing work, and probably you will have lots of other ideas that can be added, there is still a lot of room for improvement in what we can do with in the recording or in the post-processing of the conference we are handling currently. And that was all. Thank you very much. If you have any questions.
Thank you, Marcos. And great job for being your first presentation. You did an amazing job. Thanks.
I appreciate it.
Is there any question for Marcos?
Hi, Marcos.
Hi.
I'm curious, when you said that this process you described does not need transcoding, how did you actually do this? Because even if you have multiple video sources and they all have the same codec, let's say a VP8 codec, I think that you still need, in order to produce a single video as the output, I think that you still need to decode them and re-encode them. Is that right?
Well, maybe FFmpeg currently we are just basing the strategy of copy, minus b copy. So I don't think if internally FFmpeg is doing some stuff with them, but I think not. I can check it out later if you want, but I don't think we are doing anything that like copying what it's recorded by Janus and putting it together. I can confirm it later if you want.
Okay, thanks. And just another curiosity, if you can clarify a bit, how do you handle audio-video synchronization?
We are just doing basic one, that is to take the align the starting point of both recordings and putting it together, and we haven't seen any noticeable delay after we align the starting point.
So
That's been enough for us.
You're parsing the MJR header to see when the first packet got.
Exactly.
Okay. Thank you.
Welcome.
Any other questions for Marcus?
When you say recordings and transcoding, or in any case working on a file that was already recorded, the first thing that comes to my mind is disk bandwidth. Do you have any problems on this side, or do you do anything to offload this?
Bandwidth, we're just handling this on the back end, so it's internal network. The recording is done.
No, this physically store the storage and rereading things back. If you do the I/O, say.
Okay. We haven't hit any limit that we notice any performance issue. Currently, we are also not having, for saying something, we have not hundreds or concurrent streamings being processed at the same time. So disk I/O hasn't been faced any problem to us currently. Maybe, yes, storage is an interesting point also when deploying with containers, and how do you set up your clusters for storage. Maybe we hit some issue at some point, but currently it hasn't been one, so we are okay.
Do we have any more questions for Marcos, or can we move to the next speaker? Okay, thank you, Marcos.
Thank you.